Hey class, today we will use an example to show how to develop a machine learning project from end to end. Okay, here we'll look at the key steps for a machine learning project. The first step is data preparation. Second step is model selection. Step 3 is model training. Step 4 is model evaluation. The example we'll use is we will use 4 features of an iris flower. The 4 features on the left side include the petal length, petal width, sepal length, and sepal width to predict what kind iris the flower is. There are 3 kind of types: setosa, versicolor, and vaginica. So the goal is to build a machine learning that can learn from the measures of these irises whose species is known, so that we can predict the species for a new iris. Okay, now we go to anaconda. So in anaconda, we'll go to the home. On the tab all application, we'll build an application based on the machine learning environment which has created before. And then we'll use Jupyter Node. We'll launch Jupyter Node. So we'll open our Explorer, web Explorer, and where I will go to the machine learning folder where I will create a new Python code. Here I will develop the machine learning code. So the first step, we will load data and then prepare data. So to load data, the data we will load is from sklearn, which is a package for machine learning. Well, from sklearn, it's sklearn, and from its dataset. If you press tab, it will automatically show that dataset there. Or import load. If you tab load, there's many datasets we can use. So the dataset we'll use is a load iris. Okay, so once you import the load iris, and then we can load the data by using load iris function, and the data will be contained in a variable we defined here as iris. So we'll load iris function, and the data will be put in iris variable. So you either click run or use shortcut Shift Enter or Control Enter or Alt Enter. So there's many ways that you can run this code. So if I use Shift Enter after running, and we'll go to next cell that I can continue to program. Now iris will contain all the iris data we have. Okay, so let's go to look at the iris. So we can look at type iris. Type iris is a bunch object. So bunch object is very similar to dictionary in Python, which have keys and values. Then we can look at what kind of keys the iris has. So we can use iris keys function. And in this, we have data key value, target key value, frame key value, target names, and so on. So what we'll use is data and target. Data contains all the features of all samples. Target is the classification of all samples. So to access data, the way to access data is either you can use iris.data, and then Control Enter, and you'll see the data. So there are many samples. And each data sample, so each row here will contains 4 features: the the petal and the sepal width and length. The second way to access data is you can use square bracket and then use a quote inside the input data. It will give you the same result. So let's put another comment here. We have 2 different ways to access data. Here what I will do is I will assign all the features and into X. So uppercase X, that will be our features and samples. And we can look at the shape of X. So you'll see this is a 150 and 4 means there are 150 samples, and each sample has 4 features. Correspond to the features and the target iris target contains the classifications. So there will be 150 target, and each target has a type from 0, 1, 2, 3 types. I will assign this value to variable y, and you can look at y shape is also have 150, and each only have contain 1 value, which is the type. You can also look at other key values. For example, you can look at the target names, iris, see target names, and show you that corresponding to 1, 2, 3 in target, the target name correspond to Setosa, versicolor, and virginica. Another use for key value I want to show you is iris description. It's a describe the whole data set in a general way. Well, if you print out input here directly, what it shows here is have some special character. This backward slash n is change lines. If you want properly show it, we need to print it out, print iris description, and then the change line will be showed properly. So this give a general description of the data set we have. It tell you the number of instances, or instances also means samples. How many samples or instances we have is 150. The number of attributes or features. Attributes is also a feature. There are 4 numerical predictive attributes which describe the size of the flower. And the class, we have 3 classes, 0 to 1, which correspond to Setosa, versicolor, and virginica. Here's a summary statistics for all the features, and there's no missing feature, and there's minimum value, maximum value, mean value, and standard deviation and correlation. And the rest is the origin, the history of the data set. Okay, now we go to look at another one. So the feature names, and we can look at the feature names here. So we just need to change the target names to feature names, and look at that. What we have is the feature name. First one is sepal length, sepal width, and petal length and petal width. And we'll look at the file name. The file name is iris.cvs. So it's contained in the dataset in the format of CSV. We can also look at this data module. Is a sklearn datasets.data. Okay, now we have successfully loaded Iris dataset, and we have look at the key values. And the next step, we will prepare the data. So to prepare data for machine learning, what we'll do is we'll split the data set, because we have 150 instances or samples. We'll split them into two sets. One is a training set and test set. So we'll use part of the data to train the model, and then use the rest to test the model. Well, to do that, and again, we need a function from sklearn model selection import train test split. And we'll use this function to split the data we have. We have all the instance features X, all the instant classifications Y, and we'll split into two sets. One is test the train, one is train, and the test size we want to make is 20%. So you can change the value as you want. By default is 25%. If you don't assign this value, it will be 25%. And so when you split them, program will randomly split it. So you can set random state, and by assigning different value, you get different ways to split training and test data. Okay, after split it, we will put the data into X train, X test, and Y train and Y test. And then shift enter to run the data. Then we will have X train, X test, Y train, Y test. So for X train, we can look at X train that there will be 120 instances or samples, and each of them have 4 features. We can also take a look at X test. Look at the shape, it's 30. So 20% of 150 is 30. We have 30 samples, which will be used for test after we feed the model use training data. Same thing for Y train. The Y train has 120 classifications, and either it's 2, 1, or 0. So we can look at the shape. 120 Y test. That's the labeled test result. There's 30, the same number as X test. Now we finished step 1. So we load data and prepare the data. And the next step, step 2, we'll select the mode. Select a model to perform this task. The task is do classification. And here we will use a very simple machine learning model. It's a neighbor list. Well, from sklearn neighbors, import a k nearest neighbor list model. Is a k nearest neighbor model, and the job we will conduct is to do classification. So we'll choose classifier, and then we can create a model. It's called KNN based on k neighbor classifier, which is a class, and inside we can assign the value for neighbors. The neighbor we want to assign is 1. So it's a very simple model because, and the model will do is, if you want to use this model to make a prediction, it will try to find the nearest instance in the training model, and based on the training model classification, and it will assign the value to make the prediction. So this n number neighbors will assign that how many neighbors you want look at. So if you assign 1, they find the nearest neighbor. If assign 2, they find the nearest 2 neighbors, and they use the average value to make a prediction. So here we assign n neighbors 1. Now we get this kn, we write. You can look at kn will become object and created by a kn neighbors classifier class. Now we have this model, and step 3 is train the model. Train the model is also very simple. Now we have kn, and we use this kn objective functions called fit, and use the training data x train. Remember that we split the data into training data and test data, and these labels y train. So we have 120 training data, and we know its classification, and so we use this to train a KNN model after training, and the parameters of this model have been optimized, and then after that we can use it to make prediction. And then we can predict the model. We use the model to make prediction, and then we can evaluate how good is this model. For prediction, we'll use X test, and its result is true value, Y test, to see that how good the prediction will be. So to make a prediction, we can assign variable is called Y predict. We'll use a KN model predict, and the input is X test. And then we make a prediction, and then we will look at the value inside it, predict. And that's a prediction for X test. And you can compare the true value and prediction value. So Y test contains a true value. So if you compare the true values and prediction values, you will see that how good your model are. Your model, I can make a comparison of predict value and true value. You will see that based on the model for the test data set, the prediction, they're all right. Or you can use another built-in function. It's called kn score to look at the prediction. You input X test until the true value. It will see the prediction accuracy. So 1.0 means the prediction is 100%.